the bracket, huh? Alright, matching bracket, steps. Okay? Use a stack to store the left bracket. Okay? So, in this case, how are you going to answer? Okay? So, I'm going to say first step is create a stack to push, or you can say store, right? Left or open bracket. Alright? Okay? So step 2, what are we going to do? Alright? So step 2, we're going to traverse. Okay? We're going to traverse the expression. Alright? So I'm going to write as traverse expression. Okay? I'm going to traverse the expression. So what is the expression here? Okay, on the question, this is the expression. Okay, so now we're going to use illustration. Alright, so let's say I need to draw this stack. Alright, and since our expression have left bracket, remember, if it's a left bracket, push into the stack. Alright, so what was our bracket? It's a box bracket. Alright, so box bracket. Okay, open bracket, right, push into stack. After that, on my expression, I have number 3. Okay, I have number 3. So what to do with number 3? Alright, number 3, we only want to match the bracket. So 3, no need. Alright, you don't have to process it. Okay, now you can draw this way or you can draw this way. 1 bracket, you are adding in. After this, there was a curly bracket. Number 3 plus and all that, you don't have to process it, leave it as it is. Alright, so at the side, you just write down the description. Okay, so if the left bracket, push it into the stack. So you can explain. Alright, box bracket, after box bracket you have parentheses, then you have curly brace. All these are pushed into the stack. So it is explained here now. Alright. Now, next item we're going to have is our close curly bracket. Okay. Next character that we're going to traverse is a close bracket. Okay. So what we do when we have a close bracket? Okay, what we do when we have a close bracket? If, alright, the character char equal to close bracket, what we do? What we do? Alright, what we do? If it's a close bracket, if it's a close bracket, pop a bracket from a stack. Okay? So if it's a closed bracket, we have to pop. Okay? Pop bracket from stack. Okay? After that, what we have to do? We have to match it, or we have to compare it. So you have to explain and draw. Okay, so you're gonna draw a pop. Okay, we're gonna pop. Correct. It's what bracket? Box bracket. Okay, so what we're gonna pop is curly brace. So we're gonna match, of course, it's balanced. Alright, can you see that? So you're gonna say pop and compare. Okay, pop and compare. Alright, pop and compare. If it's okay, then it's a match. So similarly, you have to continue drawing and give explanation. Alright, for this question. Okay, the basic idea is use the stack to store what? You traverse the expression. If it's a left bracket, then you push it into the stack. Keywords push. If it's a close bracket, you pop. Alright, okay? Alright, next. We also have, okay, evaluating post-fix. Okay? How are we going to evaluate post-fix? Okay, this is the diagrams you can use. Alright. Now, next one is evaluating post-fix. Alright, this is also we use stack. Alright, so this time, what are you going to do? Okay, so let's say if they ask you to evaluate, okay, 6, 8, and plus. This is post-fix. Okay, so how are we going to write the steps? First thing, what are we going to do? We're going to create a stack. Alright, second, if, of course we can traverse it, right? If the character is an operand, what we're going to do? Alright, so if it's operand, this is operand, this is operand, this is operator, okay? So what we're going to do? We're going to push into the stack. Okay, so you can draw it. 6, push it in. 6 and 8. Alright? Alright, so if it is operator, what do? Alright, pop 2 operand, right? 2 value. One is for the left, one is for the right operand. Okay, then you have to perform the calculation. Okay, calculation. So from here, 6 and 8, you have to pop 6, 8, and you plus it. Results is what? What is the result? 14. Push back the results into the stack. So you have to draw this way. Okay? So make sure you follow through the steps like this. So this is another important area that you have to check. Okay? Again? Alright, revision kit now. Alright? So, any question on chapter 1? Anything you don't understand, you want me to repeat? Alright, to summarize again, go through terms, check your midterm exam questions, okay? Most important things that you have to pay attention is your ADT collections, right? List, stack, and queue. This one you have to study everything in sense of chapter 1, 2, 4, 5, and 7, okay? Okay? And then, of course, don't forget to take a look at how stack can be used for matching bracket as well as evaluating your postfix expression. Alright, so these are the important things you have to take a look at chapter 1. Okay, so now let's take a look at chapter 2. Alright, chapter 2. Alright, chapter 2. Most important thing is your specification. Alright, specification. Alright, very important. Okay, now format your coursework, follow the format. Okay, how do you write your ADT specification? So let's say ADT list, for example. You must write your description. Okay. So let's say you have a method, let's say add method. Alright, then you must have your description. What is the description? What is the precondition? What is post-condition? Alright, and what is return? Alright, so if your return value is Boolean, make sure your return will be true or false. Alright, so these are the format you must follow. Okay, very important how to write ADT specification. Okay, very important. Okay, so you must take a look at your list, stack, and queue. Okay, make sure you know how to write the ADT specification for at least your basic operation. At least basic operation. Alright? So make sure you go through. When I say at least basic operation, you have to take a look at these. Alright? Okay? This part. At least you must know how to write specification for this. So that's why I say chapter 1, 2, 4, 5, 7, you have to study one go. Alright? Yeah? Okay? Now, question may be direct. So when I say maybe direct means they will just simply ask you to write ADT specification, alright, specification for list, for example. Okay, that is very direct. Or a small case will be given. Based on that case, you have to write your ADT specification. Alright? Okay? So in that case, you might have like fraction. Alright, remember? Okay? Fraction, square matrix. Okay, so these are the examples now. Okay? So in terms of areas, okay, that you have to focus is right, okay, your interface and also implementation. Okay, so this two is coding. Alright, So for practical chapter, take a look at chapter 1. Chapter 2, 4, 5. Yeah. Okay, and sorry, for this one, practical, take a look at practical 1. I think practical 1 should do. Alright? Remember, practical 1, okay, you have this, as well as your midterm question 3. Alright? Remember we had midterm question 3. Okay, so make sure you go through that. Alright, so let's do a question. So it's easy to see if we can do a question. Alright, so let's take a look at this question. Alright, so for chapter 2, writing ADT specification, write our interface and the implementation. Very important question, will go through this format only. Alright, so let's take a look at this question. A simple calculator perform basic operation. Operation is already given to you. Add, subtract, division and multiplication. It reads two integer and display the results for selected operation. Question 1. Write an ADT specification to represent the above calculator. Include arithmetic operations such as addition, subtraction, multiplication and division. For this question, you must write ADT, let's say calculator. That's the name of the ADT. Alright? And what is the description for the ADT calculator? Okay, it says a simple calculator that perform. Alright, can you see this two line here? You just rewrite the whole line. Okay? That is the description. Alright? That is the description. ADT calculator, what is it? Description, it's a simple calculator that perform. You can see from the question itself, take the line, add it in. Okay? Next, first operation, you will have addition. So you're going to have our integer. So in this case, it's not a collection. So integer num1, num2. So your description, your precondition, your post condition, and your return. Alright, so what is the description? Add the given integer. Alright, what is the precondition? Given value or integer must be, say, positive number. Okay? For example, assumption you can make. Let's say this is just a calculator, you don't want to use a negative number, then use a negative number. Or you can say non-zero, or it has to be integer. Okay? It cannot be alphabets. Okay? So if I say the given value must be integer, then it's correct also. Okay? If I say the given value must be non-negative, okay, correct also. Alright? So it's assumption you can make. Okay? Post condition, given values are added. Okay, maybe like that. Results of the addition is written, for example. So results of addition is not true or false. So in this case, it will be written as integer. Alright, okay? So this is part of the answer. Okay, for question A. Okay? So this question here, I only did for addition. You can do the same thing for subtraction, multiplication, and division. Okay, these are the 4 operations. You have your title and description that will give you 10 marks. Each will carry 2 marks. Alright? So now, translate the ADT specification into Java interface. Okay? So how are you going to write an interface? Now this is where coding coming in. Okay? Public interface, and then you're going to say, let's say calculator interface. Alright? Okay? Now this header, this is the header. Now header, you have to write properly. Okay, interface must write. Okay, header will have about 1 mark. Okay, so you must write header properly. Okay, so this will be Java code. Alright, so it's very important for you guys to write the coding. Okay, so here you will have int addition and int and 1 int and 2. Do you write the implementation here? Interface, you don't write the implementation. Alright, don't make a mistake here. Alright, so this will give you 1 mark. Okay, you understand? So it's very important. Now the second part is the implementation. Public class. Alright, then you have the class name. Now you have to write implement the interface. Okay, this interface, alright, this one here must come here. Alright, okay? And this is a very important word. So we don't write that. That also gonna make you lose marks. Okay? So this header is important. Alright? So how you gonna write? Public, say you can have void, okay, or int, okay, addition, then you're gonna have your parameters. Here you can write return and 1 plus and 2. Alright, done. Okay, simple calculations, 2 numbers, you just return the value in. Okay, the value must come in as parameters. Okay, alright. So this is, I just showed you in terms of addition. You also take a look at subtraction, multiplication, and division. Okay. All right. So that is a question for ADT specification. Now, beside this, there's other questions that I want you guys to take a look. If you go to revision kit, you will see your ADT passive questions. All right. Okay, these two are similar for additions and all. Alright, so let's take a look at this question. If we have this kind of question, okay, earlier remember we talked about checking the bracket whether it's matched. This one is postfix. Alright, so the alphabets A, you have to change this to postfix, okay? From infix to postfix, okay? So this one also you can take a look at it. Now, let's take a look at the ADT questions, okay? Now, what to do with this, okay? Here they explain what is the ADT, all right? It consists of data and certain characteristics and set of operation. Provide characteristic and operation for the following ADTs. Include relevant examples in your answer. List ADT. Okay? So for this, let's say list. Alright? You give the definition. Alright? So here question asks you definition. Question asks you to give you characteristic. Alright, and operation. Okay? Characteristic. And then you have to check the operation and examples. Alright? Okay? So for each of it, so you have 3 marks. Okay, so basically what you're going to do is that what is a list? List is a linear collection. Right enough. If I say stack, it's a linear collection, right, where data are organized in last in, first out. If it's a queue, you can say it's a linear collection, so our data are organized, right? Or has a restriction where to add and how to remove. Okay, that is first in, first out. Correct? So these are the characteristics that you have to talk about. Okay, so here got no restriction. Okay, in terms of adding and removing or searching. Okay, so what are the basic operation? Okay, you have add. What is add? Add is to insert an element. Okay, insert what is an add? No need to draw a table as long as you can explain. Insert an element into the list. Correct enough? Then we have remove. Okay? As I say, okay, at least make sure you understand 2 basic operations, because here you'll have 1 mark, here you'll have 1 mark, here you'll have 1 mark. Okay, here's marks. Okay, now example, shopping list. Correct? Okay, so if we take a look at the question, 9 marks, each will have 3 marks. Understand? So don't write more, don't write less. Okay? Characteristic is the definition. Operation, you give 2 operation. Example, give 1 example. Done. Alright? Did they ask you to write ADT specification? No. So leave it as it is. Okay? Alright, Ken? Now, so here is an example for the add, remove, empty. Okay? This is the definition. This is the operation. This is example. Okay? Done. Okay? So chapter 2, done. Any questions? Now, of course, there are other type of questions. I want you guys to go through it. Okay? If any issue, you can check with me next class, or you can. It's best to meet me physically. It's easier to understand than sending me through chat. But of course, you can send me through chat also. Okay? So now let's take a look at chapter 3. All right? Chapter 3. Okay? Is our efficiency. Okay? Now, how can we measure our efficiency? How we measure our efficiency? Alright? There's 2 ways we can measure our efficiency. Okay? One is using experimental method. Okay? Another one is, of course, we want to analyze our algorithm. Correct or not? Okay? Now, you must know what and how. Okay? For example, we have experimental. Okay? How we measure experimental? Alright? We check the timing, time complexity. Yeah? Okay? We check the time complexity. Okay? Now, check the shortcoming. What is the problem with our experimental? What is the problem with our experimental? First thing is that, okay, it's hardware and software. Okay, what is hardware, software? Assuming, alright, so let's say you have your algorithm finished already, you test it in a very fast computer, and of course your system will be very efficient. Okay? But if you test it in a very low powered computer, of course your system will be slow. Okay? Correct or not? So it's dependent on the hardware and software. And furthermore, you have to complete your algorithm. Alright, algorithm must be completed before you can test it. Okay? And third is that the test. Okay? Test data, your input. Okay, test data, alright, will be limited. Alright? And because of this, we use analysis. Okay? We use analysis of algorithm to measure our efficiency. Alright? So, for example, of course, we use big O notation. Okay? So, this is the important part. Alright? This is the important part. Okay? For your exams, make sure you go through. Okay? What is big O notation? Why it's important? Why it's important? Because it's a hardware or software independent. Okay, independent. Alright? Okay? So you don't have to complete no need to complete your algorithm. Okay? Whatever shortcoming of your experimental, okay, we can overcome it. That's why we use big O notations. Okay? And of course, your input. Alright? You don't have to worry about the input because our input, alright, we are using big O notation. We can test in terms of how big is our input growth. Okay, so we're able to predict the efficiency. Alright, so that is the input. The most important part is to calculate, alright, your big O notation. How do you calculate your big O notation? Alright, go through how to calculate your big O notation. Alright, now this part, okay, how to calculate that, go through, how do you calculate? Alright, so make sure you go through this, and especially these algorithms, okay, how to calculate. Alright? Alright, so when we want to calculate, we have to talk about, say, if we have sum equal to n plus n times 2, for example. Okay, so this will give you a big O notation 1, because no matter how n value will increase, the time taken to process, okay, or number of operations will remain the same, 1 only. Okay, so if we have a loop, okay, let's say 1 to n, alright, so then we have sum equal to, let's say, sum plus n, for example, alright, then of course you will have your big O, and the n value increase based on that, how many times you have to loop it, alright, so these things make sure you understand. Another thing is n, so for example, okay, so here you will have 2 loops, alright? So 2 loops mean if your n value increase the inner loop, how many times you have to do the inner loop, alright? So how many operations you have to perform, okay? So the operation will increase, okay? So go through this, alright? Okay? Okay, that is done. Okay, this part, go through carefully. Okay, alright, so now next the important section. Alright, this usually question 3 coding. Alright, how do you study? Okay, ready? Okay, chapter 4, chapter 5, and chapter 7. Study together. Alright? So, of course, chapter 1, chapter 2, we already learned the basic concept of what is the list, what is the stack, what is the queue. Is that correct? Yeah? So now next we have to take a look is how to implement. Your implementation is very important. Okay, exam area. Okay. Now, what do you need to know? How are we gonna implement in terms of a linked list and an array? Okay. All right. So, how are you gonna add your list in array? How are we gonna add in our linked list? How are we gonna remove in array? How are we gonna remove in linked list? All right? Do you understand? Okay. So how are you gonna get entry in our array or get entry in our linked list? So whatever operation, you must take a look at it. Okay? So array, all right? We have the name, then the index. Index usually we keep track of it in terms of number of entries. Is that correct? Okay. For linked list, of course, we have nodes. All right. If you want to go to the next node, all right, whatever node. Yeah, next, isn't it? If you want to get access to data, use data. If you want to traverse, okay, use your current node dot next. Remember, current node equal to current node dot next. So these things all you must know. What is your first node? Okay, right? Now, let's say if we have stack. Okay? Stack. What do you need to know? You need to know top index because we want to add only on the top. Okay? For this one, linked list, you need to know your top node. Right there. Okay? For Q, you need to know your front node, front index, or we can even say first index. Right there. Depend on last or back index. Similarly, you can have it as front node, first node, or last node. Yeah? Okay? No problem? Okay. Now, I want you to take a look at the exam practice. There is a document, chapter 5, array versus link. The code is side by side for lists. Okay? How to add in array list, how to add in a linked list. I repeat, okay? This is for lists only. Do similar thing for your stack and queue. Alright? Okay? You must at least minimum must know add and remove. Okay? Not to say you must only read add and remove. I say at least minimum. Make sure you know this too. Alright? Okay? So the documents are there. You can check. Okay? Alright? So to repeat, okay? This topic mainly coding, alright? Mainly coding means Java, alright? So mainly the methods they will ask. Methods, for example, alright? You will have your add or remove, okay? Okay? So let's say if you have list, alright, if you have a list, then you will have public, okay, whatever, add, T, new entries, okay, so how do you add? Okay, array, alright, then number of entry plus return to many plus, okay, return to, okay, things like that, okay, you have to write this way, okay. Now method add implementations can be in an array or linked list, okay. So they might give you a code on array, then they ask you to change it to linked list. They might give you a linked list and ask you to change it to array, or they might just simply ask you to write the method without indicating what implementation. In that case, choose something you're familiar with, okay? So now let's take a look at the question. Alright? Okay, so question 3 here, a list ADT, okay, a linear collection, so they give you interface, alright, interface given, explanation also given, alright, question, create implementation for add, alright, position, okay, method based on the list interface using partial class array list. So what that means? Implementation has to be array implementation. Okay? So how are we gonna add in a position? Okay? Question for this. Alright? Question for this. Array implementation, a list, add in a position. That's all. Alright? Okay? Now, question. Huh? Do I have to write from the top all this? No need. They just ask you to, you see here, Boolean is given, is successful, return a value is given. You only have to add the instruction inside the add function. Okay? So for this, you copy only this line right up to here. Okay? So answer, that's answer. This is the answer. Okay? Now, question, do I have to write make room? Now, did the question say, okay, include utility function, include any function required? No, right? If no, don't write. Don't waste time. Okay? So, take a look at this question again. Okay? The question says, create an implementation for add. Alright? Using partial class array list code given below. Make room. Okay? You don't have to write it. You're not required to write it. Furthermore, in this question, make room is given. Alright? Suppose it's not given. If the question specifically never asks you, don't write. Okay? Don't waste time. And they can ask you in terms of Include any additional function mean, then you have to write. Include any utility function mean, then you have to write. Otherwise, don't write. Okay? Usually they won't ask lah. Okay? The main method only. So remove gap. Okay? And make room. All this you don't have to write it. Okay? Now, so the next question, construct same function but using a link implementation. Alright, so that's why this particular document, remember just now, comes in handy. See, this is array implementation, this is a link implementation. Alright, so make sure you understand that, folks. Okay, so that's the answer. Okay, now for this one, determine how link implementation is better in implementing list than using array implementation. Why link is better? Why link is better? Because no shifting. Alright, array we have to make room. Alright, that requires shifting. Okay, so that's why it is link is easier. Okay, better. Alright, okay. Alright, let's take a look at another question. Okay, this is a bit of old paper. I want to check the new paper, if you don't mind. Alright, let's check the last paper. Alright, let's take a look at this question. A queue is a collection of objects which follows first in, last out principle. Describe the characteristic and basic operation. Now, don't think, oh, last sitting queue came out, the sitting queue won't come out. Don't think that way, it will come out also. You never know. Okay? So, queue, how to answer this question? So, what is queue? Alright? What is the queue? Queue is a linear collection, where elements are added at the back of the queue and removed from the front. Yeah, maybe like that. Okay, so I can say elements are organized based on first in, first out. Correct? Okay. Then it says basic operation. Correct? So you can say in queue, you describe what is in queue. What is in queue? Insert element back of the queue. Alright, correct? Then you have to explain what is your DQ. Alright. Right, So maybe you can have like get from, okay, clear, empty. And make sure you give example. Okay. Okay. Now here 10 marks, so your operation has to be more. Alright, operation has to be more. You can draw a diagram because it's 10 marks, isn't it? Okay, you can draw a diagram to illustrate how data are added and removed. Okay. Alright. Okay. So next question is on circular cube. So figure 2 shows InQ method for circular cube. Write a DQ method. Alright? Write a DQ method. Alright? Circular cube, we have to find the index based on some formulas. Okay? The formula is given there already. Okay? So now how are we going to DQ? Okay? How are we going to DQ? Circular cube. And DQ is here. Alright, DQ means we have to take from the front. So we need to know our front index. Okay? Okay? Okay, so these are the things that you have to take a look. Okay? In terms of big O notation, algorithm will be given like this, then you have to come up with a big O notation. This one we have done in class. So by looking at itself, you can tell, right? So the first one is got one loop, it's going to be big O n. Second one is two loop, is big O n squared. Last one is big O 1. Okay? Okay? Right, so next part. Let me see, any other question? These are a little bit old papers, so you can get the new papers. Okay, I think these questions I already went through in class one time. Okay, all right. Now, next area is recursive. 8, 9, and 10. Okay. Now, for recursive is a standalone question, I think. Okay. Now, chapter 8, 9, and 10 is going to be together. All right. So this is your sorting, your searching. This is your binary tree. This is your hashing. Okay? Now, I'm going to go through these 3 areas next class and also our recursive next class. Okay? Okay? Now, so far whatever we learned from chapter 1 to chapter 7. Chapter 7 also same thing, whatever just now I went through is, okay, maybe you can score well, maybe no, right? But 8, 9, and 10, if you do well, you're going to get full marks. Okay? If you do well, no mistakes, straight full mark. Okay? Do you understand? Okay? Because in coding you may have 1-2 line mistake, logical error and so forth. Okay? Maybe not a full marks. But here, binary tree, you can, there's no mistake, that's it, full mark. Okay? You understand? So this one I want to keep for next class. Alright? Even if I start now, it's going to be very rushed. Okay? I want to completely go through this next class. Okay? Now, your work, do some question. Alright? And bring the question in next class and I can go through with you. Alright? Okay? Now, so far, any questions? In terms of coding, okay, you can have syntax error, but you cannot have logical error. Okay? So let's say if you want to write, okay, here, if you missed out S implement without the S, okay, fine. But if you missed out the word implement itself, okay, let's say this word is not there at all, then it's a logical error. Okay? If you just miss out the word S, okay, then it's alright. That's a syntax error. Okay, spelling wrong. Okay? Capital letter or whatever, then it's not correct. Okay? Logical error, okay, you will lose marks. Otherwise, no problem. Coding definitely is coming up. Implementation is definitely coming up. Take a look at the array implementation and link implementation. Now, one more thing I forgot. In Q, alright, for Q, you can implement with fixed front. You remember this? Dynamic front. And then you also have your circular. Alright, circular Q. So make sure you go through everything. Okay? In terms of how to add value in fixed front. Do you understand what is your fixed front means? That means your front index, okay? Front index does not move. Okay? If you remove this item, if you remove 5, then 4 will take its place. So that means we have to do shifting. Right enough. Okay? Dynamic front, we don't shift the value, but what we do with that, we shift the pointer. Okay? That's a dynamic. So what happens if I remove this, remove everything? I have only value here. Okay, dynamic front, remember? All the front is wasted. Okay, that's why we have circular. Okay? So make sure you go through this as well. Q, stack, go through. Okay? Alright, and okay. So that's it for the day. I'll see you guys next class for 8, 9, and 10. And also for recursive. Okay? If you have any question, I'm here.